Hej allihopa och välkommen igen till webbinariet om exjobbidéer. Som sagt, här ser ni lite vem som alltså arrangörerna och medlemmarna som finns med och organisationerna som finns med i våran kluster. Och idag ska fler av våra medlemmar presentera exjobbidéer. Frågor ställs i chatten eller ni har möjlighet att ställa frågor efter varje presentation. Det är ganska korta presentationer och vi har tid fram till klockan 1 att diskutera, fråga och även byta kontakter. Och med det sagt, först ska Uppsala Vatten och Avfall presentera. Jag tror ett exjobbidé kanske. Sen kommer in Mälardalens University som ska presentera lite fler exjobbidéer på engelska. Och sen kommer Stockholm Vatten och Avfall presentera ett exjobbidé också. Med det. Jag vill be Johan att dela en första exjobbidé.
Så, ser ni nu?
Ja.
Härligt. So first of all, I just want to apologize to all the non-Swedish participants here, Swedish-speaking participants here. I will do my pitch in Swedish, and the reason for that is the Swedish is the working language here at Uppsala Vatten, and to be able to carry out this project, I think it's important to understand all the internal documents and reports and so on. But I'm sure there are other interesting proposals here as well. Maybe not as interesting as this one, but I wish you the best of luck with that. So with that, I will switch to Swedish. Hallå, jag heter Johan Nilsson och jag jobbar som klimatstrateg på Uppsala Vatten. I botten är jag utbildad ingenjör inom miljö- och vattenteknik vid Uppsala Universitet och SLU. Och jag har också disputerat vid SLU vid institutionen för energi och teknik och jag har jobbat också lite på IVL med miljöberäkningar och olika tillämpningar av livscykelanalys. Så lite introduktion bara till Uppsala Vatten och Avfall. Så vi är ett kommunalt bolag som ansvarar för dricksvattenrening och avloppsrening och även dagvattenavfallshantering. Och vi är ungefär 350 anställda på bolaget. Bolaget har också mål om att vi ska halvera våra utsläpp av växthusgaser till 2030 jämfört med 2021 års nivåer. Och för att ha koll på det här så följer vi upp utsläppen varje år och det gör vi med en beräkningsmetod som heter Greenhouse Gas Protocol där man delar upp utsläppen i Scope 1 som är liksom direkta utsläpp från olika processer och så. Scope 2 är indirekta utsläpp från användning av värme och el och sen Scope 3 är utsläpp som sker både uppströms och nedströms våra processer. Så till exempel produktion av de kemikalierna som vi använder i våra processer eller hantering av det avfallet som vi skickar vidare. Och när vi kikar lite på det här så har vi sett att betydande utsläpp inom Scope 1 är utsläpp av växthusgaser från vår slamhantering. Så vi beräknar att ungefär vi släpper ut där 2800 ton koldioxidekvivalenter per år, vilket är betydande. Så det här vill vi göra någonting åt och i dagsläget så återför vi i stort sett allt slam till åkermark. Och för att göra det så behöver man hygienisera slammet. Och det gör vi i dagsläget med långtidslagring. Så nu det slammet som produceras körs ut till vår avfallsanläggning ute på Hovgården. Och sen lagras det där i ungefär 6 månader. Och under den tiden så släpps ut väldigt mycket växthusgaser, både metan och lustgas. Och vi har en långsiktig plan för hur vi ska komma till rätta med det här. Och det är att när vi bygger om vårt stora reningsverk här i stan, Kungsängsverket, så ska vi ändra rötningen från mesofil rötning till termofil, så man ändrar temperaturen i rötkammaren kan man säga. Och med den förändringen så förväntar vi oss att vi kommer minska utsläppen markant från vår slamhantering. Men det här kommer vara på plats först efter 2030, så för att vi ska ha möjlighet att nå våra mål om att halvera utsläppen till 2030 så behöver vi titta på andra åtgärder. Och där tänker vi att vi ska få lite hjälp av en exjobbare som kan hjälpa oss med det. Så vi behöver lite förslag eller utreda några kortsiktiga lösningar kan man säga. Och de 2 spår som vi har börjat kika lite på är dels ureabehandling, så man blandar in urea i avloppsslammet, och det har visat på god effekt på att minska utsläppen av växthusgaser i tidiga studier. Men vi behöver, för att kunna använda det här på Kungsängsverket så behöver vi optimera doseringen för vårt slam. För slam från olika reningsverk ser ganska olika ut. Och en sån här behandling tillför också en kostnad, så vi behöver motivera på något sätt. Så att för att det här ska vara genomförbart så behöver vi också kolla på vad kan vi uppnå för liksom maximal, hur effektiviserar det här från den här behandlingen då från en ekonomisk perspektiv, så vi kollar på hur vi kan maximera klimatnyttan per krona. Och ett annat spår som vi vill också fortsätta att titta på är om vi skulle kunna använda återvunnen kalk också för att blanda in i avloppsslammet. Och då handlar det om att i vår dricksvattenproduktion så använder vi ganska mycket kalk för att avhärda vattnet, för vi har ganska hårt vatten här i Uppsala. Och då får vi en restprodukt som är i form av kalkpellet som man kanske också skulle kunna blanda in i slammet och också kunna då minska utsläppen av växthusgaser. Och det här borde ju förhållandevis borde vara en ganska billig lösning, men vi är ganska osäkra på effekten, så det behöver vi utreda vidare. Och det finns också en risk för att i det här kalkpelletsarna så finns det även lite föroreningar i form av PFAS och några tungmetaller, som måste också utreda hur det påverkar kvaliteten på slammet i sådana fall. Precis, så vad vi erbjuder oss som annonserar det här exjobbet, att vi kommer hjälpa till med handledning. Vi har också mycket erfarenhet inom bolaget, så det finns många att fråga om de här processerna. Och man kommer också få tillgång att ta prover och så vid våra anläggningar. Vi har också samarbete eller har öppnat ett samarbete med SLU i de här frågorna, så att det kommer finnas, beroende lite på hur upplägget ser ut, så kommer det finnas möjlighet till extra handledning där och att få använda deras labb. Och vi söker då en student som ska göra ett exjobb på masternivå som har intresse för VA-teknik, miljöteknik, resurshantering, och vi letar ju efter en självgående och analytisk student som har lite labbvana, och också om man har erfarenhet av klimatberäkningar så ser vi det som meriterande, men det är inget krav. Så om ni är intresserade får ni gärna höra av er till mig, eller om ni har några frågor såklart kan vi ta det också.
Superbra, tack Johan.
Tack.
Dina kontaktuppgifter kanske finns någonstans?
Precis, de fanns längst fram, men delar du det? Jag kan skriva i chatten kanske min mejl.
Ja, gärna.
Så kan vi göra.
Gärna.
Yes.
Så ja, men tack. Spännande. Är det ett exjobb ni funderar på? Eller
det är ett exjobb.
Ett exjobb,
Ja.
okej. Och är det en exjobbare eller kan man typ, alltså ibland är det 2 exjobbare på ett exjobb också, så hur tänker ni, hur brukar ni göra?
Nej, men vi är väldigt öppna där, men vi har ju tänkt att det ska vara en exjobbare, men om man har förslag på kanske en massa breddare eller så skulle vi kunna kolla på det också såklart.
Ja. Och tidshorisonten typ, alltså vi pratar nu om studenterna ska börja så småningom. Nu är det typ dags att leta efter idéer, men är det typ när som helst eller?
Ja, vi tänker att vi ska gå ut och annonsera om det här nästa vecka lite bredare. Och sen tänker vi väl att ett exjobb kan dra igång i vår sen.
Kul.
Så det är lite tidsplanen.
Och jag tänker, alltså det blir typ i tidslinje med exjobbpresentationer i maj, juni nästa år.
Precis.
Då.
Exakt.
Ja. Men kul. Tack, jag ser ingen fråga just nu, men ja, fråga bara, ställ frågorna i chatten om ni kommer på något mer. Johan, dela gärna dina kontaktuppgifter, där Uppsala, Vatten och Avfall, så det är viktigt att ni vet också vart exjobbet finns. Och Ulf, du har en fråga kanske eller kommentar?
Ja, hej, Ulf Jeppsson, Lunds universitet. Hej Johan, jag bara undrar, kör ni någonting redan med slammet på Uppsala Vatten? Alltså med kalk eller ureabehandling? För det är ganska långsamma processer. Exjobbet är 20 veckor. Praktiska tester och sådär kräver ju minst så lång tid liksom för att utvärdera olika inblandningshalter och olika former som sen kan leda till att man kan optimera det.
Precis, vi har ju tänkt att det här skulle vara labbtester då i labbskala. Så att man tittar på det i labb då. Och då skulle man kunna göra det under...
Även där tar det ju viss tid.
Okay.
De här sakerna, för det är inte processer som bara är för liksom en timme och en dag, utan ett antal veckor får man liksom följa ett sånt prov för att se.
Men precis. Ja, precis. Ja, men de har gjort något liknande försök på Gryab, vet jag, och då följer de under ett par veckor, absolut, så är det ju. Så det gäller ju att man kommer igång snabbt med arbetet då.
Ja, rätt. Tack.
Det är verkligen en jätteintressant och viktig fråga vad man kan klara av typ under denna korta tid. Men tack igen Johan, och nu Heidi från Mälardalen University. Heidi, you are welcome to start also or share your presentation from Mälardalen University with your ideas for the master thesis, and you will speak in English.
Yes, I hope you can hear me all right.
We can hear you and we can see your presentation.
Great. Let me just move these videos out of the way. Okay, so my name is Heidi Ivan. I'm a postdoctoral researcher in environmental engineering at Mälardalen University, and I am the course coordinator for our degree project course. I was asked to come and present a couple of the proposals from our research group, sort of on behalf of everyone in the group, as I have this responsibility as course coordinator. That means maybe some of the details I will not be able to answer if there's very specific questions, but I can take up the questions with the people who have proposed the projects. So the first project that I present today is on behalf of Jan Skvarel, and it concerns real-time monitoring of wastewater using spectroscopic methods. Why do we care about real-time measurements is a good place to start. Traditional laboratory-based measurements are usually used for quality control, and they can be quite expensive. They can also be time-consuming. They almost always introduce a delay. You don't have the result at the same time that you take the sample. This makes them slightly harder to use for online process control, which really benefits from rapid measurements. Real-time measurements do not have this issue of delayed results, but are unfortunately often unreliable. This can be due to the harsh environment that we have. Wastewater is not a very pleasant place for sensors to exist in. The sensors can be fouled, they can have a lot of wear and tear, and this can mean we have a lot of interference in the measurements. But there's also the aspect of wastewater is a very complex mixture. That means we can have great challenges in detecting trace amounts or very low concentrations of very specific pollutants. But these real-time methods are evolving very quickly, and literature shows great promise to use them to detect contaminants that have traditionally been limited to offline analysis. In this project, the proposal is to use UV-Vis and near-infrared spectroscopy as a real-time analysis method to detect a range of contaminants, probably a little bit up to you and your interests, but what we have been looking into up until now is heavy metals. We have been collecting data using weekly samples from the wastewater treatment plant. These have been analyzed with traditional laboratory methods and then using the different spectroscopic methods. Here you can see two examples of how the spectrum look from the near-infrared and the UV-Vis. And in this project, if you work on it, you will have access to the existing data, but you will also have the opportunity to collect new data, develop the data set further. We have a UV-Vis spectrometer with a fiber optics probe for measuring in solutions. We also have a Bruker matrix dip probe and a micro NIR. We have other spectroscopic methods that could be used, but these are the ones that show the most promise for generating a data set that can be used for these purposes. And then the main part of the project is, once you have this data, can you do the model development? We need to correlate the spectra and the laboratory results to try and see if we can predict what the laboratory results would be from the spectrum. There's a lot of data analysis involved in this. Use machine learning methods, any sort of models that you want. I think so far we've been working with PCA-based models, but there's a lot of other options that can probably give higher accuracy. And it's still a little bit of a question. Is it possible to develop a model that is reliable enough to use? Literature supports that you can use these methods to detect heavy metal contaminants in the wastewater, but it comes back down to the complexity of the solution. Are there too many other contaminants present for us to have a high enough accuracy for it to be useful? If you have any questions or are interested in this, I would recommend reaching out to Jan Skvarel. He is the expert and will be able to give you a much bigger picture and also describe the results that they've had so far in the project and talk to you about the data in more details. The second project that I have to present is on behalf of Sebastian Schroeder. This project does not involve any hands-on experimental work. It's an exploratory study, can be done remotely if you are not able to be present in Västerås, where we're based. And the background to this project is really the update that came out last year to the Urban Wastewater Treatment Directive. We now have legislation that says we need advanced treatment methods, quaternary treatment in plants above a certain size in order to focus on the removal of key micropollutants. At the same time, legislation now talks about energy neutrality, and by 2045, wastewater treatment plants must produce as much energy as they consume. These goals often conflict. We see that advanced treatment methods can use more energy, but if we need to be energy neutral, we need to use less. So we think it's very important that before we go ahead and start implementing new systems in order to meet these requirements, we look for synergies. We look for places where technologies can support each other. And something that we've identified as interesting is hydrogen production, especially through electrolysis. Electrolysis uses electricity to split water into hydrogen and oxygen. And it's a clean process, but unfortunately it consumes a lot of water. That's where wastewater then comes in. Instead of using drinking water, which is very valuable, something we don't want to use if we don't have to, we can use treated wastewater as a feedstock for the hydrogen production. And given the goal for energy neutrality, the idea of on-site hydrogen production at the wastewater treatment plant also becomes very attractive. Hydrogen can, of course, be produced by methods other than electrolysis, so this project is not limited to looking at electrolysis, but we have some experience with this at our research group, so we would propose it as a starting point as we can offer more support in investigating this method. And then the interesting part is how the hydrogen production can synergize with the existing treatment process. For example, we can take the hydrogen that's produced and use it to upgrade the biogas, improving the methane content, making it a higher value fuel. We can also take the oxygen and feed it back into the treatment process to be used in the aeration. Aeration is one of the biggest energy consumers in the wastewater treatment plant. So if we can reduce the energy consumption here, make it more efficient, that would be very valuable. And the main research question then is, well, can these same synergies be extended to quaternary treatment technologies, like advanced oxidation, adsorption? Can the oxygen or hydrogen support pollutant removal? Can we use waste heat? And it's a very open project inviting for exploration in these ideas. We want to see what advanced treatment technologies could work well with the combined generation of energy. And again, if you have questions, I would point you at Sebastian Schröder, as he is the expert on this and can provide more details. The final project that I present is part of a project that I'm working in called Unity for Water, where we are looking at using treated wastewater for agricultural irrigation. Water scarcity all around the world pushes us to look for new sources of irrigation water, and due to the high nutrient content, nitrogen and phosphorus, in wastewater, we think it is a very promising option. But before we can safely use it for irrigation, we have to make sure it is disinfected, free from harmful pathogens and contaminants, and that it meets legislative requirements. This is an excerpt from the most recent water reuse guidelines. Within our project, we have chosen to use ozone for this disinfection. Ozone is an extremely powerful oxidant. It reacts quickly with organic pollutants and microorganisms, but it doesn't discriminate. It can also oxidize the valuable nutrients that are in the water, like the nitrogen and phosphorus, which we want to keep for irrigation. Here you can just see some results from some preliminary tests we did, where you see it's very easy to remove the E. coli, for example, but if you just do it the simple way, you end up removing all of the nitrogen from the water as well. Literature supports that you can do selective ozonation, where you manage to remove the key contaminants while retaining the nutrients. And that is what we want to achieve in this project. And a good place to start, we think, is to model this. We can do experimental work using synthetic wastewater solutions, where we start with a very few number of constituents in the water, maybe a couple of key contaminants, and then we gradually make it more complex and develop the model so we can understand how the ozone reacts under different conditions with different compounds. The ozonation is not cheap energy-wise. We really need to find a way to make it most efficient, to remove as many contaminants as possible while removing as few nutrients as possible. And I think that is all I have to say. We have many more suggestions on many different topics. Here's a QR code just to the page from our research environment where we post degree project suggestions, but I'm happy to take any questions now.
Thank you, Heidi. Please share also your contact detail here in the chat, because we have seen the email addresses from the other colleagues, but not yours. And this is really good. Thank you for sharing all these different ideas, because one on the lab scale, one on the more theoretical exploratory scale, and one in the modeling scale. So it's good to have this variety. Thanks for that. Let's see, questions are not yet there. Maybe also, I mean, time-wise and location-wise, and how the setup with one or two students is. You can say something about how you are usually doing this, or how the routine is at your university?
Yes, so I would say all of these are ongoing projects, so it's not limited to any particular time frame. Somewhere between now and next summer is good, or even going into next autumn. We are open to having up to 2 students working on a project together. And if it's involving lab work, it's here in Västerås, but there is the one project that can be done remotely.
Great. Thanks a lot. There is no questions rolling in, but hopefully you will have some questions on the email at least. Thanks a lot, Heidi. And last but not least, there is coming in a question from Ulf. And until then, I can actually ask just to prepare for Andrei for the last presentation from Stockholm Vatten. And please, Ulf, raise your question or comment.
Yeah, sorry if I'm the only one asking questions. But if nobody else have questions. So first, Heidi, the first project you're focusing on heavy metals.
Yes, that's
due
correct.
to history of previous work, or I mean, in many cases we would be very happy if we had the simple like UV and near infrared sensors work properly for various both soluble and particulate COD and for nitrogen and so on, which can be more directly used in control as well. But here you're looking more at monitoring, I think. And
yeah, it was based on a request from the wastewater treatment plants that we collaborate with. They wanted a way to monitor the metals without waiting for the lab analyses. But we obviously do have the potential to look at the COD or the nitrogen because we have the data. So it's possible to extend to that.
Yeah, good. And just a comment to the work on electrolysis. I saw in a report from 2024 from Svenska kraftnät. They are estimating that in 2050, something like 20% of all the electricity in Sweden will be used for various electrolysis purposes. They're foreseeing a great use of hydrogen, and as you know, it's already starting with the steel production in the northern part of Sweden, and they see it increasing dramatically over the next few decades. So certainly an important aspect. And the third one, which was on ozonation, basically you are thinking of so to ozonate the effluent from the wastewater treatment plant, to disinfect it in a sense. Well, not only disinfect, but get rid of various compounds that may be unwanted if you want to use it directly for agricultural irrigation.
We've actually been working mainly with the reject water stream as it has a higher nitrogen content and is therefore more important also to disinfect.
You think of the reject stream, yeah. Well, as long as you potentially there's some pre-treatment needed as well to get rid of nitrate and so on, that can also be fairly high. And before you use ozonation, you don't want any nitrate in the water, since it will dramatically increase the amount of ozone that needs to be used. So is that potential use of pre-treatment also a part of the thesis work that you propose?
It can be. Whatever is needed to do the selective ozonation, we haven't dug too deep into it yet. We got the ozone generator installed and up and running, so we now have the ability to do the experiments in the lab, and we'll start digging into it in the next year.
Okay, so you have a small ozone generator now in the lab available. Excellent. Yep. Good. Thanks, Heidi.
Thank you.
Great, thanks for your really good questions. So it's needed some discussion points. And now, please, Andrei, if you can share your master thesis idé, om du kan dela din exjobbidé från Stockholm Vatten och Avfall.
Yeah, let me see. I just share my screen and we'll see if you see it.
Yes, we see it, and now it's coming into presentation mode. We see also your explanation slide.
Yeah.
Yes.
Let me see if I can fix it. Yeah.
Yes. No, it's fine.
Yeah. So the project is focused on PFAS removal. I don't have a slide on what PFAS are, but that's a group of substances which has a very high potential for carcinogenic effect, and usually it's found in firefighting foams. And in municipal wastewater treatment plants, usually, or up until now, it was not that high of an issue. It was mostly for high concentrated streams that was a problem. But now there is the legislation actually requiring some kind of treatment, or at least concentrations in the water, in the natural water, and there are some rules for sludge handling regarding PFAS. And there are coming new legislations. There is coming new legislation both in Sweden and on EU level, which could mean that in future some wastewater treatment plants would be required to remove PFAS. And actually in Uppsala, in their new permit, they have a limit on PFAS discharge to the coastal water with their treated wastewater. So this project, this master thesis project is a part of a bigger project, mainly cooperated with IVL and Käppala, but also other plants and financed from Svenskt Vatten. And the idea is to use foam fractionation technique. It's a technique where you aerate the water, and then PFAS stick to the air bubbles and rise, and then you collect the foam and thereby collect PFAS. And then you can do it in a few stages. So you separate the foam, you collect it, then you do it again, collect the foam from this concentrate and can up concentrate it a lot of times. So these systems are available for high concentrated, low volume streams, but not for municipal wastewater yet. We did some studies in a bench scale, and these are some of the results. So this is both are from Stockholm. One is from Civic, which is a research facility which is operated by IVL, where we, Stockholm Vatten, have our pilot plant, and then from Käppala. So as you can see, if you look on PFAS or PFAS4, which are the most important, then we can remove, depending on where we apply the process, from somewhere from 70 to 95% of PFAS. But that's results from small scale. So the next step is to scale it up to pilot scale. Yeah, and there are some results about the sludge. I will not go into detail on that. So we got a new project, and what we will do, we will continue this kind of small scale trials in a small column, but also we will integrate it into big pilot plants. So here we're talking like 3 cubic meters per hour of water coming in, and then we try to collect the foam in different stages of the biological treatment. And then when we have it, we try to concentrate it again to see how much we can remove and how high we can reach the concentration. And then we also try MBBR, and we also try for digested sludge, the same thing. So the work is going to be performed at Sjöstadsverket Water Innovation Center, SWIC, which, as I told, is operated by IVL and partly KTH. That's a facility where we have several pilots which we run in cooperation with IVL. So it's more like a wastewater treatment plant in a small scale. We already started doing some tests. Here you can see actually we have one master's thesis student working now from Mälardalen University, and he's doing the trials in a small scale, collecting foam. We actually are here today and also do trials. And then we also started with some work on installation this foam collection equipment in a bigger scale. So if I go back to this slide, so we are somewhere here that we did this one, and we are trying this part of the system, but the master's thesis student will mostly focus on the whole integration. So this pilot is going to be built now during the probably beginning of the next year. So some work of the student will be on the actual collection, for which we don't need the pilot, and then when the pilot is there, then we can integrate it and run everything together. So the main question for the project is how can foam fractionation be integrated in municipal wastewater treatment plant, and that will be investigated by pilot trials on foam collection and then on the further concentration. So 2 places where we actually extract the foam and then how we concentrate it further. And then, of course, analysis of the results and evaluation of possibility for full-scale application. How to apply and whom we are looking for. I would be industrial supervisor from SWA. That's my email address. I will write it in the chat as well. Then we have other practical supervisors from SWA and IVL. The work will be practically oriented, so a lot of experiments. So good if there is some experience in pilot operations, in lab, chemical lab, and so on. And we at least looking for someone who is able to be here every day. It doesn't mean that it will be every day in half a year, but it's some work can be done from home. But yeah, we want the student to be engaged and be here as much as possible. Application, send me email if you're interested. Don't send any other documents. We will have a recruitment site ready, like a page, and there you will submit your documents. So those who send me email, they will get the link in a week or so. And then you need to submit CV, cover letter, grades on university level. And for evaluation, we value mostly the person took wastewater treatment courses, and then grades are very important. We look a lot on that. So, and then also lab experience. There will be a few rounds of interview, decision in November. We have a bonus of 30,000 crowns for successfully completed projects, according to our policy. That's everything I have now.
Thank you very much, Andrei. Great. All the details have been added that is needed. Maybe that's why no questions yet, at least. Please share your contact details also in the chat.
Yeah.
I don't see any questions right now. Thank you. And we have 1 minute left.
A question from Professor Ulf Jeppsson.
There is a question from Ulf, please.
Just a follow up on my previous line of questions. So thanks, Andrei. The IVL has been doing quite a lot of testing of foam treatment over the last number of years, and sometimes in lab scale it has seemed to produce good results. And now you want to scale it up and see what the possibilities are. So my question is just, do you know, is there anyone anywhere in the world that is using the foam reduction technique for PFAS in full scale today?
Yeah, there is no application for municipal wastewater treatment. There are full-scale plants for leachate treatment and for treatment of polluted groundwater and polluted stormwater from like firefighting training sites and these kind of things. But there is no it's one thing to treat 30 cubic meters per hour and another one 10 cubic meters per second, which is our design flow. So that's one of the thing, and we want to mostly develop this like a first stage, how we extract it and make a smaller stream, and then the other technology providers can work further with these stream and concentrate it further destruct.
Yeah, because it's huge amounts of water.
Yeah, exactly.
And what's the usual potential treatment of the foam that is taken out?
Yeah.
So what happens to that afterwards?
Yeah. So if you look on previous study and full-scale plants, then they could reach a concentration degree of around 1 million, which means that for like Henriksdal, it would mean 2.5 cubic meter of concentrate per day, which is not much. If you send it for high treatment incineration, which costs around maybe like 10,000 per cubic meter, that's like 20,000 per day. That's not much for a scale of Stockholm. And there are also destruction technologies that could be applied on site, mostly electrochemical techniques.
Yeah. Okay. Thanks, Andrei.
Thank you. And there are also questions. Andrei, where is Svik located?
Yeah, Svik, if you Google, I can actually show you. Hela skärmen. So it's located in Stockholm. It's if you search for Ludden reningsverk. So it's here. It's next to Kaknästornet, for those who know. So there is a bus from Central Station which stops like 10 minutes walk, and you're there.
Mm-hmm. And also one more question to you. When is the deadline to apply? And do the students, do they email for the link to apply, or should they wait for it to be updated in the website?
Yeah, they can email me and they just say that I'm interested in this, and then as soon as it's published, probably like next week, I'll send them the link and then they can apply. Usually we have like a period of at least 2 weeks for people to apply, so maybe until the end of November, but we will look on the applications like from the beginning. So if you are interested, don't wait to the last day. I think the last day, which will be officially stated, will be like middle of December, but until then that's just like if we don't get any applications, then we wait to that date. But probably like in the beginning of November, we find a person. And actually we have another master thesis project, but there we already found a student who will be working on pharmaceuticals removal at Henriksdal.
Great. And also the last question, if it's possible for English speakers to apply.
Yeah.
Great.
No problem with but sometimes we get question about if it can be 2 students doing one project, and the answer is we prefer 1 student per project.
Yeah. Okay, so 1 student project, yes.
Yeah.
And that's great. And also please share your contact detail in the chat as well, Andrei, so that the students can contact you. And thanks a lot for the students. I am sharing a last slide because, I mean, we have been talking in the region at the East Coast, and I'm sitting on the West Coast in Gothenburg. So just something for the students and for everyone to know could be interesting. And that is actually the young water professionals from the International Water Association, which is actually having representatives also here in Sweden. And now it's dark everything. And actually they will have an exhibition as well with master thesis ideas in case any of you is in Gothenburg on the 21st of October in the afternoon at Chalmers. There will be this event that the young water professionals are arranging, and you can talk also about master thesis ideas there. With that, I would like to thank you